week at a glance, we are on Wednesday already, so you guys should have answered your Steam Media post, discussion post. So it's due today. Also, we had a puzzle yesterday, so if you have not done that, please do so. I just wanted to emphasize everybody, don't wait the last minute until you start doing work because it's just gonna build up. You know, easy things becomes harder, hard things become harder. But please make sure that we get our tasks done ahead or on time so that work won't be piled up. Ms. Watkins, would like to add something more?
No, just keep up the good work, you guys. Keep up the good
And those who are working consistently, you guys are rock stars.
superstars.
Yeah.
Like this, you guys. Look, superstar status.
Right. Awesome. So that's that Thursday's quizzes. And then on Friday, which we are going to explain to you guys what that siphon is, we'll get that after we're done for today explaining about water. Very
and
nice.
In case anybody was wondering, our class pet also enjoys the water. He's doing pretty good. Check out his video on that. But notice he's chilling out with some water molecules, right? Remember, H2O. But he needs those. So just in case you were wondering, he's fine. He doesn't have a name, though, so we might want to think of a name for him.
Okay, so two things today. We are going to do some slides about water. We'll learn more about water. Sometimes we wonder why water behaves that way, so that's actually what we're going to talk about. And also, we'll have some water experiment challenge. Properties of water is what we're going to talk about. If you look at that very beautiful picture and also my background, that's water. And we're going to take a look at its properties. What's with water? What's special about water? And also, why is that properties of water important in the Earth's dynamics? So,
Fun fact. Who knows what all of this water is called? When we talked about spheres at the very, very beginning of the year, we talked about spheres: geosphere, lithosphere, atmosphere, biosphere, and I'm seeing hydrosphere. Very good, you guys. Hydro flask
to every hydrosphere. That's right. And which is why we're going to take a look at the properties, because water is such an important and special molecule that we have with us. That's why it's very important to drink water. It's hot today, so we got to do that. But before anything else, while you're watching in this short video, I want you guys to think about why water behaves this way, okay? And then we're going to call someone to share their answers after we watch this video. Let's take a look. All right. You see that? Pretty cool, huh? And I'm sure some of you at one point, is there anyone who had done this before? Putting drops of water on top of the penny without spilling. I see that challenge.
Oh, no, do a green check mark. Very good. Do a green check mark if you've done this experiment before. The penny surface tension. Green check mark.
13 people said yes. 7 people no. Nice. So I see that challenge happening, and I want you guys to kind of like think about that. Maybe that's one of our water challenge later on, and you can do that. You can have some, the medicine dropper that you have at home. You can try that out. And it has to do with the behavior of water. And we're going to take a look at the properties of water, and one of them is this property. Mm-hmm. And I'm going to tell you about that when we get through our discussion today.
Hey, you should have a penny. Hold it up. Hold your penny.
Guys.
There you go. Because remember, you matter, like this penny. But you matter more than the penny, actually. So good job.
All right. So we know that water is a very special molecule that's in our planet, and it is something that's odorless, tasteless, transparent, liquid, and exhibit a bluish tinge. We don't normally see that bluish tinge, but actually that has to do with when light passes through it, it creates that kind of bluish tinge. And it's 70% of the Earth's surface and make up 60% of our body. And 92% of our blood is water. That's why water is a very important substance.
And I know you guys learned that when last year with Mrs. Abraham, right? Cells, they're made of organelles. There you go. Cells, they're made of organelles. And the organelles need water to function. So
water.
Just
yes,
saying.
Exactly. We'll take a look at the properties of water. What's special about it? And we know that life needs water, and therefore we need to also understand the properties of water. So we're going to take a look at these properties of water: being a polar molecule, having a hydrogen bond, soluble. It has a surface tension, and this is the only substance that can exist in 3 different states. We're going to look at that. There's also freezing and melting point of water, density, and specific heat. So we're going to take a look at that quickly just to explain to you why water is very, very, very special, mainly because of all of these properties that it possesses. So we'll take a look at being a polar molecule. So when you go to high school, you will learn more about the partial negative and partial positive charge of water. So when oxygen and hydrogen actually bond together, it creates this charge. And therefore, the characteristic of water's partial negativity makes it easier for water to bond with other molecules. So that's why when you make your Kool-Aid, it's easy to mix it together with water because of its polar nature. Another property of water is solubility. It's the ability of the substance to mix together with water. So if you look at this diagram, which Mrs. Watkins is going to show in a few minutes, that when a substance is dissolved in water, they mix right away, and it mixes uniformly with the water molecule. So it causes this attraction that's happening between the substance and the water, and that's called solubility. And water dissolves more substance than any other liquid. That's why water is such a very special substance. And we also call water as the universal solvent because it makes almost anything that we combine it with.
Super solvent.
Yeah. And also the dissolving power of water is very important in life, and because it carries these minerals, chemicals, that is, of course, used by living things. So that's why solubility is a property of water, because it carries everything. So like your blood, water is mostly, your blood is mostly water, and that water carries these minerals in your bloodstream distributed all over your body. That's it. And so let's take a look at this super saturation demo. Mrs. Watkins, take it away.
So, Kool-Aid. Go ahead and give me a check mark if you've ever had Kool-Aid before, or hot chocolate, or the squeeze bottle kind, or whatever. If you've ever drinking something that has a powdery substance that gets dissolved in water. I should be seeing 107 check marks, right? There should be no red X's. I at least hope not. If you haven't hot chocolate yet, I'm sorry.
Who knows? Maybe they're not allowed to drink at home with a Kool-Aid. You know?
And maybe it's not Kool-Aid, yeah, because Kool-Aid has a lot of sugar in it too, and artificial flavors and all that kind of fun stuff. But anyways, I put the Funko Pop guy there to imagine, the Kool-Aid guy to have our little demo example. But with that, what happens when you pour in a little bit of Kool-Aid? Does the water stay clear? or does it start to change color? Who can raise their hand and talk us through what happens when you pour Kool-Aid into a clear cup of water?
I'll unmute you if you would
Oh, I
like
see
to
a couple.
share.
Aiden, can I get Aiden?
Aiden,
Can we unmute you, Aiden? Aiden, talk it through to me, buddy.
Aiden, yes. Aiden, you're unmuted.
So when you pour powdery substance like the Kool-Aid into the water, it starts to dissolve and the water starts to change, have color and flavor.
Yes, sir. Thank you. Great explanation. Great explanation. As it starts to dissolve, who can add to Aiden's explanation? When you pour in the powdery substance, when do you stop?
Noah is raising his hand.
Do you get another packet? When do you stop?
Noah? Well, Noah. Hang on, Noah. Let me unmute you. Noah, go ahead.
When you pour in the packet, it turns to red, and once it's all dissolved and the water is all red, that's when you probably should stop.
Could you keep going?
You could, but it would make it more strong or potent flavor.
Very good. Stronger flavor and darker color. Thank you, Noah. I'm going to get one more person now. Give me three.
One more who would like to share.
What happens if you keep pouring the Kool-Aid? Or actually, I really do this one with the squeeze bottle and the syrup for strawberry milk or chocolate milk. You know, you keep squeezing and you keep squeezing and you keep squeezing, or you keep pouring the powder, keep pouring the powder, keep pouring the powder. What happens to that solution eventually? Who can share that with us? Jonas, can I pick Jonas?
Jonas?
Okay,
Jonas.
So I'm gonna use like a real word example. Hello, but so me and my mom, we've been making like cranberry lemonade, and so we bought like that big thing from Costco, right?
Yeah.
And so my mom was just like, all right, can you make some? I was like, yeah, sure. And she goes, well, put two little not spoonfuls, but like cups. So I did that. And then later at dinner, I was like, all right, we should take it out and try it. And then when we tried it, it was like, it had like, I think the more, like the bigger the container it is, the more you need, because it tasted really like, it didn't taste strong enough. Like you could taste more cranberry than the lemon.
Yeah.
So right now, when you guys are talking about this, I'm like, oh wait, yeah, that happened yesterday.
Real world example. Jonas, that is a STEAM-IO right there. You better lock that down because that's a STEAM-IO point. And put that on the Padlet. Post it to the Padlet. And I saw Richard, and then Sienna. Those are the next two I wanted to call on. Richard, what you got? What happens if I keep pouring solution or keep squeezing in the chocolate milk or strawberry syrup?
Richard?
It just collects at the bottom because all of the mixture or the water molecules have absorbed like as much as they can, so then it just sinks to the bottom because it can't absorb anymore.
Does anybody want to guess what the word of today for that particular example is?
That word I just said.
On the slide. Saturation is part of it.
Yes, type it on the chat box.
It's not just regular saturation.
It's, come on, look over there. Look over the screen. Come on.
Decompose saturation? No.
Super saturation.
Oh, super saturation. Thank you, Zoe.
It's
Thank you, everybody else. Thank you, community.
Got it.
Super saturation.
Danica
Very good. The example, just like you said. Sorry, Mrs. White. I'll just finish this. The example, when you can no longer dissolve anymore, it's called supersaturation. It'll start to collect at the bottom. So then it becomes a precipitate instead of a solvent and a solubility inside of it. And for the solute, it starts to go at the bottom. And you can also think about like a sponge when you're washing dishes or something, right? When you fill up the sponge with water, it can't keep taking more water. The water just starts to flow out, right? But you have to squeeze the water out in order to soak it back in to fill up more. Right? But supersaturation, one of my favorite science words. Thank you guys so much for talking that out with us. That was fun.
All right. And also, there's another property of water, which is called surface tension. So it's just saying that molecules of water stick together through cohesion to form that water, kind of like not stick, but they kind of group together. So if they see other molecules of water, they tend to join in together. So that's called cohesion. So it's even strong enough to support a very light object. As you can see on this picture right here, this bug on top of the water, that is surface tension, which is another property of water. And see this light coin on top of water? That's another example of surface tension. You call that cohesion. So this one you can try on your own if you want to try the surface tension of water. So we'll get going. So there's another surface tension properties of water. We call it cohesion. We saw that they clump in drops, so that's why on top of the penny they're there, you know. But there's another property of water which is called adhesion. So from the word adhere, it sticks to other polar substances. So that's why if we actually like shower, for example, if you haven't done that, try it. That water tends to stick to other polar substances, which is like our skin. So the sweat sticks to our skin because your sweat is composed of water, and it has that property of adhering to another polar substance. So that's called adhesion. So the penny experiment that we saw is the cohesion, and then adhesion is like it sticks to other polar substance as well. Cohesion is together with other water molecules. Adhesion, it sticks to other polar molecules.
And as we're talking about this, thinking back to the water cycle, right? Remembering when we were talking about the spheres, remembering we're talking about the cycling throughout. The reason we sweat, that would be an interesting challenge to look up. I can tell you, but I'm not going to, right? Look it up. Why do we sweat? All right. Water is coming on the outside of our skin, so our body releases it. But then what happens to it? Right? Where does it go? Does it just stay there? Sometimes it does, and it drips because you got too much, right? But why does your body release water from the inside to the outside? What does it do that for? I don't know, right? That actually I do know, but I want you to know. I want you guys to go and explore that. We'll put these challenge questions on the Google Classroom afterwards so that you guys can start exploring those.
I think we have one answer though. Danica said we sweat because it cools down the body.
Yes, it does. And that's once upon a time in real life, Mrs. Watkins / still kind of does play sports a lot, and I used to sweat / still do a lot. And I was always like, Dad, why do I sweat so much? And he's like, well, your body sweats to cool it down, just like you said. Very good. And then I was like, well, then I guess what's going on? He's like, yeah, it's like your body's air conditioning system, you know? Or you turn on the fans, you know, you open the window, it's your body's air conditioning system. And you know what I said, guys? I said, well, I guess my air conditioning system is working really good. And he's like, okay, Christina.
Okay. Yeah, exactly. And that has to do with the properties of your body. Cells.
Everybody's body is different. And that's the other thing. Everybody's body is different, and everybody matters. Good job, you guys. Keep it going. Go ahead, Ms. White.
Yeah, exactly. And also, just a fun fact, if you guys don't know, water is the only natural substance that can exist in all 3 states of matter. Let's
at the same time.
3 states of matter. Who knows? What are the 3 states of matter?
Type it in the chat.
Anybody? Nobody? Solid, liquid, and gas. Good job, Logan. That's it. So we know that water can be in a state of gas, liquid, and solid. And that's one unique property of water. And of course, each state requires increase or decrease in energy so that water will change from one state to another. Mrs. Watkins?
Thank you. Remember, you guys, we did the hand motions with this one, with the particle movement. Solid, show me with your hand. Solid is together. They still vibrate, but they're really close together. Adding heat and energy makes they break apart a little bit, and now they're flowing. All right, good. And then when you add more heat and energy, then they go faster, and they go faster. And the 4th phase of matter, anybody know the 4th phase? Remember, type it in the chat. It's the most abundant phase of matter in the universe. However, it's not very abundant on Earth. So we have solid, liquid, gas, and
And plasma.
plasma. Very good.
Awesome.
Very good.
Awesome. And of course, we know this is we're just looking back. Water can freeze or melt. It depends on what you want to do with it. Right now, I want the water to be frozen because I want to put in my water so that it cools me down because it's really hot today. And of course, water has freezing point and melting point. They're actually about the same. So if you notice at the temperature, melting water, 32 degrees Fahrenheit or 0 degrees Celsius. And pretty much it's the opposite of the other, 0 or 32. And the temperature to cool, to maybe lower if supercooling occurs or there are impurities in the water. So that's pretty much what this other property of water is. And water is has density, and most liquids become more dense with a decrease in temperature as their molecule slows down. So an example of density is if your water is in a liquid state, it has a certain density and it usually is higher. Now, when your ice or your water turns into ice, it actually becomes less dense as it cools and expands. So if you look at the diagram, there's kind of like little holes in between in your ice structure that causes your ice to float. And while if it's in a liquid state, if you notice, there's no gaps in between of the water molecules because it is in a liquid state. So that is called density.
And that's a fun fact too. Water is one of the only molecules that its solid state is less dense than its liquid state. And just thinking about the ramifications of that, what would happen if solid water froze and sunk? Think about all those little...
That leads us to this one right here. If water acted like most other liquids, lakes and rivers would freeze solid and all life in them would die.
Yeah, that's a good one.
So, and lastly, we have specific heat capacity. So this is a property caused by hydrogen bonding of water molecules. So remember, water has hydrogen, 2 hydrogens and 1 oxygen. And specific heat has to do with the amount of heat that a substance can take to increase its temperature. And we'll explain that diagram in a few minutes. And water takes a long time to heat up and a long time to cool. And it's 5 times more than sand. So if you look at the diagram in here, so the sun has the same amount of energy that radiates in your water and your sand, but between the water and the sand, there's small temperature rise in the water compared to the sand, which has a larger temperature increase. So that's called specific heat. And that's the reason why water affects our climate. It stays cool longer and acts as a coolant. So water acts as a coolant. And also, it stays warm longer, and it also acts as a heater. So that is a very special property of water as well. And we observe this every day: sea breeze, cool summer days, and warm winter days. And this accounts for the amount of precipitation around lakes and ocean, mainly because of the specific heat capacity of water. So this is just something that you can think about. Maybe you can share in the chat some questions before we end, kind of like looking into heat capacity that we observe in real life. So think of a time you have observed the ground being hotter than water, okay? So I'm sure in the beach, we live here in a gorgeous sunny San Diego, so I'm sure you guys have observed. Yep. What happens to the temperature of land and water on the shoreline at night or during the day? So let's think about that. So let's start first with the nighttime. What happens to the temperature of land and water on the shoreline at night?
Anybody want to
Yes.
type in the chat?
So Kirsten said it gets warmer than in the day, right? And
Good.
how does the specific heat capacity of water protect the fish during the winter? Why do you think? How does the specific heat? Remember, that is the amount of heat that water can take in to increase its temperature, right? And if it's a winter time, I'm a fish. How is the water protecting me? Anybody? How? So remember, we go back to this diagram.
Keeps them alive and doesn't make them frozen. Good movie also. But yeah, keeps the fish warm. It keeps their body temperature where it needs to be so they don't get frozen fish in the ocean, right?
In the ocean. And of course, that amount of heat that water is capable of taking it in and letting it stay actually protect the fish during the winter time because of that certain specific heat capacity that water can take in. You know, that temperature, that heat to take in for a period of time in order for the fish to stay protected during the winter time. So just to sum up what we talked about before we get into what our challenge is going to be for Friday, we identify the physical and chemical properties of water, and we also describe how properties of water are important to the planet's dynamic.
All right. So for our challenge for this week for Friday, we would like you to pick a particular property of water and do a little experiment with it. You can watch some videos, you can replicate one, but we not only need you to do it, for example, like the penny, you could do the penny example and then explain the science. Because science, why? Like, what did the science do? All right.
Bye,
Hey guys, get it out and sign it out. Bye.
Bye.